Alrighty, so in this video, we are going to be working on translations in the coordinate plane. So don't forget, a translation is when we slide a shape, either left, right, up, or down. So Roberto is going to be using a computer design program to make stickers. He draws triangle, that symbol stands for triangle, ABC, in the coordinate plane. Then he translate ABC 5 units left. So we're going to take this image 5 units to the left to formulate triangle A prime, B prime, C prime. So the little exclamation point is read prime, kind of like Amazon Prime, except you're not getting a package. Sorry. And just a couple vocab words. When we see triangle ABC, so his first image, we call that the pre-image. And then after he translates it, when we get A prime, B prime, C prime, that is called the image once it's translated. So pre-image and image, there's no post-image. So he is taking it 5 units to the left. So to do that, we are going to take every single coordinate and count it over 5 spaces. So we're going to start here and go 1, 2, 3, 4, 5. And we're going to call that A prime. Then we're going to take coordinate B, count it over 1, 2, 3, 4, 5. We're going to call that B prime. And then we're going to take C and count 1, 2, 3, 4, 5. And that's going to be called C prime. And then we're going to connect our points to form the shape. Now, if you notice, these sides are still the same and the angles are still the same. That's exactly what we want to see, because remember the fancy word congruent. The shapes are congruent. They're equal in size to one another. So we want to kind of get a rule here. We want to be able to translate this without even having to do it on a graph necessarily. So we're going to make a table. We're going to compare triangle ABC to its image A prime, B prime, C prime. And we're going to do it by comparing each of the coordinates. So we're going to find coordinate A and compare it to A prime. We're going to find coordinate B, compare it to B prime. And we're going to do the same with coordinates C and C prime. So they already gave us A's coordinates. A's coordinates were 4, 8. The new A prime has coordinates -1, +8. Remember, we always go left and then up. So someone used to say, you run before you jump. So the coordinates for A prime are -1, 8. B started at 4, 4, and then B prime ended up at -1, +4. C started at 1, 5, and C prime ended up being at -4, +5. So what do we notice about the pre-image coordinate compared to the image coordinate? So before it was translated, after it was translated. Well, one thing that I'm noticing is that the y coordinate never changed. The y coordinate stayed the same. Why might that be? Well, y is the up and down movement, right? So the y coordinate stayed the same because ABC, triangle ABC, didn't move up or down. Let me zoom out just a pinch. So of course the y coordinate wouldn't change. Now let's look at the x coordinate. I went from 4 to -1, 4 to -1, 1, 2, -4. So if you notice, each x-coordinate was 5 less. 4 minus 5 is -1. 4 minus 5 is -1. 1 minus 5 is -4. So the x-coordinate subtracted 5 because if you think about it, going left is a negative movement, right? Moving left this way, the numbers are getting smaller. So you have to subtract to go left. So let's look at page 18. So flip over to page 18 and let's try to come up with a generic rule for this. So we're not going to do number 1. We just did that. But let's look at our original point, 4, 8. So that's where we're starting. That's our pre-image. The rest of these are our images. And we want to see, what do we notice? So let's look at let's do the y-coordinate first. When I translated left, my y-coordinate stayed at 8. When I translated 4 units left, my y-coordinate was 8. When I translated 2 units right, my y-coordinate was 8. And when I translated 4 units right, my y-coordinate was 8. So you'll notice the y-coordinate stays the same. Left and right does not change the y-coordinate because remember, y is up and down. So going left and right doesn't change your y-coordinate. Now let's look at the blue. So I started at 4. When I went 2 units left, I ended up at 2. That's because going left is a subtraction movement. Your numbers are getting smaller going to the left on the x-axis. So here we did x minus 2. When I went 4 units left, I started at 4. I ended up at 0. So here we subtracted 4. A left movement is subtraction. When I went 2 units to the right, if I started at 4, I would have ended up at 6 because going to the right on the x-axis, your numbers get bigger. So going right is adding. And then when I went 4 units right, I went from 4 to 8 because I added 4. So for the x-coordinate rather, 2 things are happening. If we go to the right, we're going to add. If we're going to the left, we're going to subtract by however much we're going to the left. So left and right only changes x, right turns to addition, left turns to subtraction. If we look at B is going only up and down. So let's start with the x-coordinate. Going 2 units up, x is 4, 4 units up, x is 4, 2 units down, x is 4, 4 units down, x is 4. So moving up and down doesn't affect x because x is left and right. So our first observation is the x-coordinate stays the same. Now let's look at the y. So it started at 8. When I went 2 units up, I went from 8 to 10. That's because going up is increasing your y-coordinate. So here we added 2 to the y-coordinate. When I went 4 units up, I went from 8 to 12. So y increased by 4. 2 units down now is going to be decreasing the y-coordinate. So instead of being at 8, I subtracted 2 to get to 6. If I went 4 units down, starting at 8 brought me to 4. So the y-coordinate is going to change. If we go up, we're going to add. If we go down, we're going to subtract. So before we do number 3, let's just take one point. Let's take the point 4, 8. Let me write it in black. So let's take the one we've been using, and let's go left 3, and let's go up 7. So left 3 is going to affect the x coordinate, and so I'm going to do 4, 8. I'm going to affect the x coordinate by subtracting 3. Up 7 affects the y, so I'm going to go plus 7. So left 3 affected the x, up 7 affected the y, and so my new coordinate is going to be 1, 15. So if I had x, y, and I went 5 down, so down is y. So I'm going to subtract 5 from the y coordinate. So instead of being x, y, x won't change because when you go down, you don't change the x coordinate, but y is going to be 5.